Hey guys, welcome to this session by Intellipaat. Apache Kafka is used for building real-time data pipelines and streaming applications. Uber, Spotify and Slack are few companies who use Kafka in their technology stack. And in this session, we'll be learning about Kafka comprehensively. And also before moving on with this session, please subscribe to our channel so that you don't miss our upcoming videos. Now let us take a quick glance at the agenda. We'll start off with a quick introduction to Kafka and its features. And after that, we'll look into Kafka topics and partitions. After that, we'll look into the workflow of pub/sub messaging. Moving on, we'll be looking at the various CLI tools in Kafka. And after that, we'll learn how to configure a single node in Kafka. And finally, we will do the multi-node cluster setup. Also guys, if you want to do an end-to-end certification training on Kafka, Intellipaat provides a complete certification training on Kafka and those details are available in the description. Now let us begin this session.
Let's start up by understanding what is the need of Kafka. So the current day industry is emerging with lots of real-time data that needs to be processed in real time. So this is the 21st century and all of the top organizations over there are generating a lot of real-time data. So let's just look at some examples. So we've got sensor data that is used to predict the failure of a system ahead of time. Now we've got all of these sensors generating real-time data, and it's very important to understand and process this real-time data in a very quick way. Similarly, we've got real-time economic data that is based on the preliminary estimates and is frequently adjusted for better estimates to be available. So this is all of the financial data which is being generated from the stocks and so on. And if we tap into this real-time data which is generated by the stock market, then it could be a huge boom for our economy. Now, what happens is all of the organizations can have multiple servers at the front end and back end. So we can have multiple servers at the front end like web application server for hosting websites or applications. And we can also have a lot of back end servers. Now, all of these servers will need to communicate with the database server. Thus, we'll have multiple data pipelines connecting all of them to the database server. So this is what we have. So let's say we've got this organization which has all of these servers over here. So this is the front end and this is the back end. So we've got the front end server, we've got a couple of application servers over here, and we've got a chat server. So similarly, at the back end, we've got a database server, a security system server, and we've got a real-time monitoring server, and we've got a data warehouse. Now, all of these servers which are present at the front end would want to interact with the database server, and not just the database server, but all of the servers which are present at the back end. So if you see over here, these are all of the data pipelines which are present. Now, let's just take the case of this front end server and this database server. So you see that these are all of the data pipelines which connects this front-end server to the database server. Similarly, these are the data pipelines connecting this application 1 server to the database server. Now, we've just got 4 servers at the front end and 5 servers at the back end. And we've got like almost 50 data pipelines connecting these servers at the front end and back end. And these are a huge amount of data pipelines. And dealing with all of these data pipelines can be a very cumbersome and time-consuming task. So as we see that the data pipelines are getting complex with the increase in the number of systems, and adding a new system or a server requires more data pipelines, which will make the data flow even more complicated. So let's say I go ahead and add a couple more front-end servers and a couple more database servers over here. Then just imagine the number of data pipelines interacting over here. So that is a very complex system, isn't it? And managing all of these data pipelines becomes very difficult as each data pipeline has its own set of requirements. So if you got 1,000 data pipelines between the front-end servers and the back-end servers, then managing all of these 1,000 data pipelines is a very, very cumbersome task. And even adding or removing some of these pipelines is difficult in such cases. So this is where Kafka comes in to solve this problem. Now, Kafka is basically a messaging system. Now, what is a messaging system? So just consider that this is a system which is there between the front-end servers and the back-end servers. And this basically decouples all of the data pipelines. Now, what happens is you've got producers which produce all of the messages or generate all of the data. And all of that data is stored in the form of a stream in the Kafka cluster. Now you can consider Kafka cluster to be a group of servers which are known as brokers. Now, all of this data is being generated in real time from these producers, and that data is stored in streams in this Kafka cluster.
Okay guys, a quick info. If you want to do an end-to-end certification on Kafka, Intellipaat provides a complete certification training on Kafka, and those details are available in the description. Now let us continue with this session.
Now this consumer generates a request and it takes in or consumes the data from this Kafka cluster. So this is how the process flow goes. So the producer generates all of the data which is stored in the Kafka cluster, and from the Kafka cluster the consumer consumes all of the data. Right, so we see that the number of data pipelines have decreased over here. Right, now let's understand what exactly is Kafka. So Apache Kafka is an open source, distributed, publish subscribe messaging system that manages and maintains real-time stream of data from different applications and websites. So this basically means that this is an intermediate system between all of the producers and all of the consumers, or all of the front-end servers and all of the back-end servers, and it basically provides a proper system with which we can deal and maintain the real-time stream of data. So Apache Kafka basically originated at LinkedIn. Now they had a problem to solve where they were dealing with huge amounts of real-time data. So that is why LinkedIn thought of using a publish subscribe messaging system, and they came up with Kafka. Now once they understood how important and valuable Kafka is, that is when it later became an open source Apache project in 2011, and then it became the first class Apache project in 2012. Now just a simple fact. So Apache Kafka is written in Scala in Java, and it is extremely fast, scalable, durable, fault tolerant, and distributed by design. So these are like some basic features of Apache Kafka. Alright, now let's properly understand the solution provided by Kafka. So what is happening over here is Apache Kafka basically reduces the complexity of the data pipelines, and it makes communications between systems simpler and manageable. And with Kafka, it is very easy to establish remote communication and send data across a network. So you can establish asynchronous communication and send messages with the help of Kafka. So what do I mean by asynchronous communication? So this basically means that the producers over here keep on sending the messages in the form of a stream to the Kafka cluster, and they do not have to wait for an acknowledgement from the Kafka cluster. Right? So these producers will keep on sending the messages which would be stored in the Kafka cluster, and they would be consumed by all of these consumers over here. So this sort of ensures that there is a reliable asynchronous communication between all of the producers and all of the consumers. Right. Now let's go ahead and look at all of the Kafka features. So Kafka is highly scalable in nature because it has distributed systems with no downtime. Now, what do I mean by distributed systems? So let's say if you had just one server which would take care of all of the messages consuming from the producers, and only this server sends all of the messages back to the consumer. Now, dealing with this huge amount of data by a single server is very difficult. So this is where we've got something as a Kafka cluster, where we've got multiple brokers, and all of these multiple brokers simultaneously take care of all of the messages coming from the producer over there. And Kafka can also take care of huge volume of data. So Kafka can take care of terabytes of data which is continuously being generated by all of the producers, and it can seamlessly send them to the consumers at the back end. And Kafka also provides fault tolerance, because let's say if there is failure of one node, then all of the data which is present in that particular node would have replicas stored in some other systems. So let's say if there is one broker which fails, then the data which is present on that broker would also be present in 2 or 3 more brokers, right? So this is how Kafka provides fault tolerance. And Kafka also provides reliability because it is distributed, partitioned, replicated, and fault tolerant. Next, Kafka also provides durability because it uses distributed commit logs. That is, messages persist on the disk as fast as possible. So the producer sends a message, and this message is immediately stored in the form of a distributed log in the disk. And the performance of Apache Kafka is also very, very good. Now, when I say performance, what I basically mean over here is high throughput. And what do I mean by throughput? So throughput is basically the amount of information which is being passed in a particular amount of time. Or let me just say that Apache Kafka enables huge amount of information being transferred in just 1 second of time. So this Kafka cluster can take in terabytes of messages from the producers in single second of time and then transfer these messages to the consumers in a single second of time. So this is what is known as throughput. So over here you have something known as the producer throughput and the consumer throughput. So producer throughput is the amount of information which the producers generated in a particular amount of time, and the consumer throughput is the amount of data that the consumers can consume in a particular amount of time. So this is how Kafka ensures that there is very high performance. And Kafka also provides zero downtime. Now Kafka is very fast and guarantees zero downtime and zero data loss. And another feature of Kafka is it is extensible. So there are many ways by which applications can plug in and make use of Kafka. So you can use it on any platform and use it for multiple purposes. Right, so now that we've looked at some of the features of Kafka, let's go through the components of Kafka. So let's start off by understanding what exactly is a Kafka broker. So Kafka brokers are the servers that manage and mediate the conversation between two different systems. So this is basically that server which makes sure that all of the messages which are coming from the producer are properly stored in the Kafka cluster, and it also ensures that these messages are properly consumed by the consumer. So this is the intermediary between the producer and the consumer, or between the front end and the back end. And brokers are also responsible for the delivery of messages to the right party. So next we'll understand what exactly is a message. So messages are simple byte arrays, and any object can be stored in any format by the developers. So the format of these messages could be in the form of string, JSON, Avro, and so on. Right? So simply put, messages are just simple byte arrays which are sent from the producer, and then broker sends it to the consumer which requests for it. Right? Now we'll understand what exactly is a topic. So in Apache Kafka, all the messages are maintained in what we call as topics. So consider it like this. So let's say there's this huge organization and there is data related to different things. So there could be data related to sales, there could be data related to accounts, there could be data related to technology, and there also could be data related to analytics. Now, all of these could be different topics. So let's say I just take up sales over here. So sales would be one particular topic. Now, all of the messages which are related to the sales topic would come under one category. So over here, topic basically means that there is a particular category of messages which could be clustered into. And all of these messages are stored, published, and organized in Kafka topics. Next, we'll understand what exactly is a cluster. So in Kafka, more than one broker, that is, a set of servers, is collectively known as a cluster. So when you have just a single broker, so it is just a one broker Kafka architecture. And when you have more than one broker, that is what is known as a Kafka clusters. So it's basically a group of computers, each having one instance of a Kafka broker. So let's say if you have 3 computers, then all of these 3 computers or servers would have one instance of a Kafka broker. So next up, we'll understand what exactly are producers. So producers are the processes that publish data or messages to one or more topics. So these would come at the front end, or these are basically entities which would generate all of the data, and they are basically the source of data stream in Kafka. Next, we'll understand what are consumers. So consumers are the processes that read and process the data from topics by subscribing to one or more topics in the Kafka cluster. Right? So we already know that consumers are used to consume data from the Kafka cluster. Now, the consumers can either consume one or more than one topic. Right? So let's say there's this one consumer group and it wants to consume only data or only messages related to the sales topic. There could be another consumer group which wants to consume data and with respect to the analytics topic as well as the tech topic, right? So this is how consumers work. Next, we'll understand what are partitions. So every broker holds few partitions, and each partition can either be a leader or a replica for a topic. Now what basically happens is when topics are sent from the producer to the consumer, these topics are divided into partitions. So you don't really send the entire topic as a whole from the producer to the consumer. So these are divided into a set of partitions, and these partitions are what are stored in the cluster. And all writes and reads to a topic go via the leader, which is responsible for updating replicas with new data. And unfortunately, if the leader fails, then the replica takes over as the new leader. So this is why Kafka is known as fault tolerant. Now let's go ahead and understand the architecture of a Kafka cluster. So we've got producers over here, and these producers send messages in the form of topics and which are received by the consumers over here.
Okay guys, a quick info. If you want to do an end-to-end certification on Kafka, Intellipaat provides a complete certification training on Kafka, and those details are available in the description. Now let us continue with this session.
Now, as I've already told you, these topics are divided into partitions. So over here, this is a one broker cluster. So these producers send a topic to this broker over here. Now this is just one topic, right? Keep this in mind. So we've got topic 1, and this topic 1 is divided into 3 partitions. So we've got partition 0, partition 1 and partition 2, and all of these 3 partitions are stored in a single broker over here because this is a single broker cluster. Now this topic would be consumed by the consumers which are present over here. So this is the basic architecture of a Kafka cluster. And the same thing is happening over here. So we've got data or the topic which is sent to the broker over here. And this is a single topic over here, and the single topic is being divided into 3 partitions. Now, when the producer sends this topic, it is basically stored in the form of what is known as offset. So consider that there are 3 messages which are being sent by this producer over here, right? And all of these 3 messages correspond to the topic 1. Now, message 0 and message 1. So each message is tagged with an offset value over here. So let's say there is message 1 which is tagged with the offset 0, and there is message 2 which is tagged with the offset 1, and there is message 3, it is tagged with the offset 2 over here. So this is how it happens. So all of the messages are tagged with an offset value and are stored in this cluster over here. And whenever the consumer requests for this topic, it will get it from the broker. Now let's understand the workflow of a Kafka producer. So these producers send records to the topics. So these records are nothing but the messages which are sent as topics to the broker. Now these producers select the partition to send the message per topic, right? So these are like randomly selected, and these producers just select one particular partition to send one particular message per topic to these partitions. And these producers can implement priority systems which are based on sending records to certain partitions depending on the priority of the record, and they send these records to a partition based on the records key. So producers don't really wait for acknowledgements from a broker and send messages as fast as a broker can handle. So this is the asynchronous communication which we are talking about. So these producers keep on sending these messages or records to the broker over here, and it will not wait for an acknowledgement back from the broker. So as and when the broker can handle all of these messages, it will keep sending these messages to the broker. Now let's understand about the Kafka broker. So a Kafka cluster typically consists of multiple brokers to maintain the load balance. Now, as I've already told you, if there are multiple messages being produced by the producer, then handling all of them by a single broker would be a difficult task. That is why we've got more than one broker, which is known as a Kafka cluster. And a broker, on receiving messages from the producer, assigns offsets to them and commits the messages to the storage on the disk. So as you see over here, these are basically the offset members. So this partition or this broker has received these 2 messages from the producer, and it has assigned these offset values to these messages, and it has stored them on the disk. Now this broker serves the consumers by responding to fetch requests for partitions. And one broker instance can handle thousands of reads and writes per second and terabytes of messages. So that is really huge, isn't it? Right? So if we just take this one particular broker over here, this one broker itself can handle thousands of writes per second and terabytes of messages. Now, backups of topic partitions are present in multiple brokers. And if a broker goes down, one of the brokers containing the backup partitions would be elected as the leader of the respective partitions. Now, let's understand about Kafka topics and partitions. So, messages in Kafka are categorized into topics, which we already know. Now, again, let's take the same example. Let's say there's a school and there are different tables over there. So there would be one student table, there would be one teacher's table, and there would be one table related to departments. Now, we can consider all of these 3 different tables to be 3 different topics, and there would be data pertaining to these 3 different topics over here. right? So the messages or the data related to these three different topics are categorized individually into these topics. And these topics are basically broken down into a number of partitions. And these messages are written to it in an append-only fashion. Now, what do I mean by append-only fashion? This basically means that I've got a producer over here and it sends the first message or the first record, which would be given the offset 0. After that, it'll go ahead and send the next message, which will be assigned the offset 1. And then it will send the next message, which will be assigned the offset 2. So you can actually not go back to the earlier messages, or you can skip one particular message and go forward, right? So this would happen in an append only fashion, and you will be writing message by message. Now this is how producers write the messages into the broker. But reading messages is different. So reading messages can either be done in the order from beginning to the end, or we can actually skip certain messages, or we can actually go behind, or we can rewind to any point in the partition by providing an offset value. Now, let's say this consumer A wants this message at offset 0 from partition 1. Right now, it doesn't have to read this message and it can only read this message over here. Similarly, if there's consumer B and if it wants to read only this message with the offset value 1 from partition 2, then it can do it and ignore these two messages. So this is how consumers work. Now this offset value is basically the sequential ID provided to the messages. And another thing to keep in mind is partitions provide redundancy and scalability. So partitions can be hosted on a different server. That is, a single topic can be scaled horizontally across multiple servers, thus enhancing the performance. Right. Now let's take this example to understand how a topic is basically divided into different partitions. So this figure shows that we have a topic which is divided into 4 partitions with writes being appended to the end of each of these partitions. So this is the topic, and this topic will have one particular name, and it has been divided into 4 partitions, and these are partition 0, partition 1, partition 2 and partition 3. And these are all of the messages which are present in partition 0, right? And the writing takes place at the end of this, right? So we basically append the next message over here. Similarly, the same thing happens at partition 1, partition 2 and partition 3. Now, a record is stored in a partition either by the record key if it is present, or by round robin if the key is missing. So this is the basic default behavior, right? Now let's understand about replication. So if we take the same example where we have a topic and that topic is configured into 4 partitions. So this is partition 0, 1, 2 and 3. And if we set the replication factor of a topic to be equal to 3, then Kafka will create 3 identical replicas of each partition, right? So this partition would have 3 replicas, partition 2 would have 3 replicas, partition 0 would have 3 replicas, and partition 3 would also have 3 replicas. Now all of these replicas would be present on the available brokers which are present in the cluster. So let's take this partition over here. Now since the replication factor is set to 3, there would be 3 replicas of this partition over here, and the ID of the replica is the same as the ID of the broker that hosts it. So over here the ID of the broker is 2, right? Since this is broker 2, that is why the ID of the replica will also be 2. So this is replica 2. Similarly over here this is broker 3. Or the ID of the broker is 3, and that is why the ID of the replica will also be 3. Now after all this is done, for each partition, Kafka will elect one broker as the leader. And out of these 5 brokers over here, this broker has been elected as the leader. And if this broker fails due to some unfortunate incident, then one of these 2 brokers, either broker 2 or broker 3, would be elected as the leader, because this has a replica of partition 1, right? Now, finally, let's understand about the Kafka consumer. So the Kafka consumer can subscribe to one or more topics and read messages in the order they were produced. So it's not a necessary that every consumer has to read only one particular topic. So it's totally fine if one consumer reads more than one topic. And the consumer can keep track of all of the messages it has already consumed by keeping track of the offset of messages. So let's say consumer A reads this message which has offset value 0. Now to remember that it has already read the message at offset value 0, what it will do is it will keep a glance at the offset value. And since it knows that it has already read the offset value 0, then it will go to the next offset and it will read the message which is present at offset number 1. So consumers can also work as a part of a consumer group. So as we see over here, we've got a consumer group. That is, we've got one or more consumers that work together to consume a topic. So over here, we've got 3 consumers present in a consumer group. We've got consumer A, consumer B, and consumer C. And all of these 3 consumers are consuming only this one particular topic. Now, messages with the same key arrive with the same consumer. And this consumer group basically assures that each partition is consumed by only one member. So over here, partition 1 is being consumed by only consumer A. Partition 2 is being consumed by only consumer B, and partition 3 is being consumed by only consumer C. Now let's look at this working mechanism.
Okay guys, a quick info. If you want to do an end-to-end certification on Kafka, Intellipaat provides a complete certification training on Kafka, and those details are available in the description. Now let us continue with this session.
So over here again we've got these 3 consumers in a single group consuming one particular topic. Now we see that consumer 0 is working on only one partition, which is partition 0. Similarly, consumer 2 is working on a single partition, which is partition 3. But consumer 1 is working on 2 partitions simultaneously, which are partition 1 and partition 2. Now this is also possible when it comes to consuming messages with the help of the consumer. But the only thing which matters is that all of the offset values are in check. Over here, consumer 1 reads offset value 5 and 7. Consumer 0 reads offset value 6 and consumer 2 reads offset value 10. So if all of the consumers work in tandem and maintain the synchronicity, then there would be absolutely no problem. Right. Now let's start off by understanding what exactly is Apache Zookeeper and how does it help when it comes to working with Kafka. So let's actually start off by looking at the definition. So Zookeeper is an open source Apache project that provides centralized infrastructure and services that enable synchronization across an Apache Hadoop cluster. Now this is a very complicated definition. So what do we mean by this? Now Apache Zookeeper comes in whenever we are working with any sort of distributed applications. Now if it is a distributed application, for example Kafka, so this would obviously run on multiple systems. So you have multiple nodes working together parallelly. Now when multiple nodes are working together parallelly, like again let's take Kafka. So you've got a multi-node cluster setup. Let's say you've got multiple brokers, you've got multiple producers, and you've got multiple consumers. Now all of these brokers, consumers, and producers have to work parallelly in sync. Now there could be a lot of cases where this does not happen, right? So either the broker might fail, or the messages sent by the producer would not have been received by the brokers, or there could be a case where the consumers are not able to process the information sent by the brokers. So to make sure all of this is working properly in sync, we would need Apache Zookeeper. So Zookeeper makes sure whenever we are working with any sort of distributed application, all of these work in tandem. It provides a lot of services. So one of those services which Apache Zookeeper provides is the naming service. Now what do we mean by naming service? It basically means that it is sort of like a DNS, but just for the nodes which are present in this cluster setup. So with the help of Apache Zookeeper, we can identify which brokers are present in our cluster currently and which producer is sending what messages to our broker currently. Right? So all of this naming information is present. And also it is used to elect the leaders and the slaves. Now it is very important when it comes to cluster setup to have one leader and the rest as the workers, so that there is a proper workflow maintained. Now what happens if the leader itself fails? So if the leader itself fails, then Apache Zookeeper maintains a list of all of the workers which would have the same topics present in them. Now Apache Zookeeper would go ahead and elect one of these slaves as the leader. So this is where Apache Zookeeper comes in. And not also this, it also makes sure that all of the topics which are present in the partitions, they have the relevant offset numbers. And it also makes sure that these messages are properly sent to the consumer. Right, so these are all the services which are provided by Apache Zookeeper. Now just a bit of information about Apache Zookeeper. So it was originally developed at Yahoo and it facilitates synchronization in the process by maintaining a status on Zookeeper servers which store information in local log files. And Apache Zookeeper servers are capable of supporting a large Hadoop cluster, which we have already known. Right. So this is the Zookeeper architecture. So we've got all of these servers. So these are the server applications and these are all of the client applications. Now, all of these server applications work parallelly and all of these client applications also work parallelly. So let's say there is this client which sends a request to this server application over here. Now, if this client does not get an acknowledgement from the server, then what happens is it will not wait for a long time and it will send the acknowledgement to the next server. So this is how parallelization works in, right? So if one server doesn't respond to this client, then immediately that request is sent to the next server and it will wait for the acknowledgement from this server in the brief amount of time. And if even the second server does not respond to this client in that specified amount of time, then that request is sent to the third server and it will be responding to this particular client over here. So this is how Apache Zookeeper works. Now let's see how Zookeeper and Kafka work in tandem. So the Kafka brokers coordinate with each other using Zookeeper, right? So over here we've got just one broker, but let's say it is a multi-node cluster setup or a multi-broker cluster setup. So if you have multiple brokers, then all of those multiple brokers need to work with each other in tandem. Now that is possible by using Zookeeper, right? So this is how the Kafka brokers work. And then producers and consumers are notified by the Zookeeper service about the presence of a new broker in the system or about the failure of a broker in the system. So let's say as of now, we've just got one broker in this Kafka cluster. Now suddenly we decide to scale up the process and we add two more brokers in the system. Now when we add two more brokers in the system, then these two producers and these three consumers would have to know about the presence of the new brokers. So this is where Zookeeper comes in. So Zookeeper, it notifies these two producers and these three consumers that listen, I have added two more brokers into this Kafka cluster and whatever messages you'd be sending, that would be processed parallelly by all of the three brokers over here. Right. Now, if the leader node fails, then on the basis of the currently live nodes, Apache Zookeeper will elect the new leader. So I've already told you about this. So let's see if one of these partitions is elected as the leader and that partition fails, then the other partitions which are currently alive, one of those would be made the leader. And Zookeeper in Kafka keeps a set of in-sync replicas. So this is how Zookeeper maintains synchronization between producers, consumers, and brokers. Now let's look at the Kafka workflow. So the producers will start off by sending messages to a topic at regular intervals. So let's say there is one particular topic and the topic is related to football. Now the producer will publish or send messages to that particular topic at regular intervals. After that, the brokers will store the messages in partitions configured for that particular topic. So let's say this topic football has 3 partitions, then these messages would be stored in these 3 partitions. Now, if a producer sends 2 messages and there exists 2 partitions, Kafka will store one message in the first partition and second message in the second. So this is how it works. Now again, let's take our football topic over there. As I've said, let's say if this football topic is divided into 3 partitions and we are sending around 6 messages. Now, the first message would be stored in the first partition, second message would be stored in the second partition, third message would be stored in the third partition. Now again, the fourth message would be stored in the first partition again, fifth message would be stored in the second partition, and the sixth message would be stored in the third partition. So this is how it works. And after that, once the producer sends all of these messages and it is stored in the broker system, then a consumer would always subscribe to a specific topic. So over here, we've got consumers and these consumers would subscribe to our football topic. And when the consumer subscribes to a topic, Kafka provides the current offset of the topic to the consumer and the offset is saved in the Zookeeper ensemble. Now, let's say we've got this consumer which reads the first 2 messages which are present in the partitions. So over here, the offset value would become 2. Now, since it has read 2 messages, the offset value becomes 2 and it is stored in the Zookeeper. Now, going ahead, the consumer has to read the third message which would be present in the third partition. So, the consumer would know this by looking at the offset of the currently consumed message. And for new messages, the consumer will request Kafka in regular intervals. Now, as soon as the message is received from the producer, it is forwarded to the consumers. And on receiving the message, consumer will process it. And once the message is processed, an acknowledgement is sent from the consumer to the broker. And once the broker cluster receives the acknowledgement, the offset is changed to a new value and it is updated in the Zookeeper. Now, the consumers are also able to read the new message correctly even during server outages since the offsets are maintained in the Zookeeper. Now, let's say we've got this producer over here and it continuously keeps on sending messages. and there are, let's say, 100 messages in total, and the server breaks down when it has sent around 57 messages. Now, there is no need to worry anything at all, because the offset number would be stored in the Zookeeper and the offset value of 57 would be there. Now, once the server goes back up, the consumer can start consuming messages from the offset number 58 because of the help of Zookeeper. And this flow repeats until consumer stops the request. So this is the entire workflow of the messaging system. Now let's look at some of the top companies which are using Apache Kafka. So these are the top companies. So we've got Samsung Electronics, Homebase, Square Incorporation, Herman International Industries, and Nanigans Incorporation. So these are all of the top companies which are using Apache Kafka for distributed processing and distributed synchronization. Now Intellipaat already provides the Kafka setup for you guys, so you don't have to worry about the setup at all. So you can just go through the support documents and you'll be able to figure it out. And if you have any doubts, you can reach out to our support. So they are available 24/7. Now this brings us to the end of the module. Now let's just go through a quick quiz to recap all of that stuff. So we've got our first question over here. Now each Kafka partition has one server that acts as, so what do you think is the answer? Right, so the answer is leader. So each Kafka partition has one server that acts as the leader. Then we have our next quiz over here. So Kafka provides only a dash order over messages within a partition. So Kafka provides only a total order over messages within a partition. Question number 3. So Kafka maintains feeds of messages in categories called, so what would be the answer to this? So the answer is topics. So all of the feeds of messages are stored in categories called as topics. All right. Right, so let's start off by understanding the Kafka cluster. Now, whenever we are dealing with small amount of data or we are working in a local development work, then it's fine if we are using just a single broker. But let's say we have huge amount of real-time data and we have around 1 terabyte of real-time data coming every single second. Now, to process this 1 terabyte of real-time data every single second, one broker wouldn't be enough. So we'd have to scale this load across multiple servers. So this is where we would need multi-broker system setup. Now, instead of using just one broker, what we'll do is we'll have multiple brokers and all of this data would be scaled across multiple servers so that the load across one single broker is reduced. Now, another advantage with respect to multiple broker setup is the topic is not just sent as a single topic. It'll have its replicas as well. And when a single topic has multiple replicas, this would also give in more fault tolerance. Now also, as we have seen, a Kafka cluster is effective for applications that involve large-scale message processing. Right, so now let's go ahead and look at some Kafka command line tools. So the Kafka cluster can run against this following broker setup. So we can either have a single broker cluster or we can have multiple broker cluster. So in single broker cluster, we just have a single broker which would serve all of the requests. And when we have multiple broker cluster, what happens is the load is divided across all of these multiple brokers. And these are some of the commonly used commands. So we'll start off with Zookeeper server start.sh. Now, whenever we are working with Kafka or real-time processing, we need Zookeeper. So to start Zookeeper, we would have to run this command. So we'll type in Zookeeper server start.sh. So as we see over here, it starts Zookeeper using the properties configured under config/zookeeper.properties. So in simple terms, this command line is basically used to start the Zookeeper service. And then we also need to start the Kafka service. So this is the command. So we'll type in Kafka server start.sh. And this is the description. So it starts the Kafka server using the properties configured under config/server.properties. Now, when it comes to topics, we'll use this command. So we've got Kafka topics.sh, and this command is used to create topics, list topics, delete topics, and modify the topic. And then we've also got producer and consumer. Now we also have Kafka producer and Kafka consumer. So as we all know, producer is used to send messages to the Kafka cluster. So this is the command. We'll type in Kafka console producer.sh to send messages to the Kafka cluster. And then we also know that consumer is used to consume messages, and this is the command to create a consumer. So we'll type in Kafka console consumer.sh. And so as it is stated over here, it is a command line client to consume messages from the Kafka cluster. All right. Now let's look at the different types of Kafka clusters available. So first we have single node, single broker cluster. So in a single node, single broker cluster, we just have a single node. Now, what do I mean by single node? So single node basically means a single system. So in this single system, we have a single Kafka broker over here, and we have producers sending messages to this single node, and these messages would again be consumed by all of these consumers over here. So we just have a single system or a single node, and in that single system, we have a single broker present. And that broker is responsible for maintaining the balance between the producers and the consumers. So next we have a single node multiple broker cluster. Now this means that inside a single system, so a single node basically means a single system. So inside this single system, we have multiple brokers. So as we see over here, we have a single system, and inside this single system, we've got 3 brokers. Broker 1, broker 2 and broker 3. So these producers send all of their messages to this cluster over here, right? So this is a multi-broker cluster, and these consumers consume the messages from this multi-broker system. And then we have a multiple node multi-broker cluster. So when it comes to multiple node multi-broker cluster, we have more than one nodes. Or in simple terms, we've got more than one system. And in more than one system, we've got multiple brokers present inside it. So as we see over here, this is system 1 and system 2, or node 1 and node 2. And inside node 1, we've got broker 1 and broker 2. And similarly, inside node 2, we've got broker 1 and broker 2. So over here, these producers send their messages to node 1 as well as node 2. And similarly over here, this consumer, we see that it consumes messages from this node, and these two consumers, they consume messages from this node over here. So this is how a multiple node multi-broker cluster works. Now it's finally time to go ahead and configure our single node single broker cluster. Right, so these are some prerequisites we should have so that we can configure our system. So we need to have Java, Kafka and Zookeeper pre-installed so that we can go ahead and set up a cluster. Alright, now to set up a single broker, so we'll have to start off by opening our terminal, and we'll launch the services of both Zookeeper and Kafka. So as we have already seen, to launch the Zookeeper service, we'll type in Zookeeper server start.sh, and after that we will go ahead and launch this Zookeeper. So Kafka/config/Zookeeper properties. Now this is basically the path where this is present. So inside the Kafka folder, there is this configuration directory, and inside this configuration directory, there is this properties file, which is Zookeeper properties. So this helps us to launch the Zookeeper service. Now similarly, to launch Kafka, we'll type in Kafka server start.sh, and inside the Kafka directory, we have the configuration directory, and inside the configuration directory, we have this server.properties, which would help us to launch the Kafka service. Right, so we are starting off the Zookeeper service, and we are also starting off the Kafka service. Alright, now to see if both of the services are running or not, we'll just type in JPS, and this would give us all of these results. So this Kafka over here, this basically means that Kafka is running, and this quorum peer main, this means that even the Zookeeper daemon is running. So both the Kafka daemon and the quorum peer main daemons are running. So now that we've started the Kafka service, it's time to create a topic and send it from the producer and consume it from the consumer. So this is how we can create a topic. So as we had seen earlier, this is the command to create a topic. So we'll type in Kafka topics.sh, and then we'll type create, and after that we'll initialize Zookeeper, and then we'll set a localhost port number. So we are setting up the localhost port number to be equal to 2181, and the replication factor which we are setting up is equal to 1. After that, we'll also set the number of partitions to be equal to 1, and then we'll give the name of the topic. So here the name of the topic is example 1, right? So basically we are creating a topic where the replication factor is 1 and the number of partitions is also equal to 1. Now if we want to have a glance at all of the topics which are present, then we just need to type in Kafka topics.sh list Zookeeper localhost. So this would give us all of the topics which are present, right? So now that we have created a topic, it's time to launch a producer. So this is the command for that. So we'll type in Kafka console producer.sh, and we'll give in hyphen broker list, and then we'll give the port number where the producer sends these messages. So it is 9092, and then this is the topic which the producer is sending. So topic example 1. So example 1 is the topic which is being sent by this producer. So we have launched the producer. Now we have to create a consumer to consume or process all of these messages. So we'll use this command over here. We'll type in Kafka console consumer.sh, and then we'll start this bootstrap server, and we'll set the local host to be equal to 9092 because both the producer and consumer are listening at the same port, and this has subscribed to the topic example 1. So the producer is sending the topic example1, and also the consumer has subscribed to the topic example1, and it is reading the topic from the beginning. Right, so when it reads the topic from the beginning, this is the result which it gets. Hello, this is my first example. Right, now let's go ahead and actually perform this. So this is Putty. I'll just go ahead and log in. So this is the ID over here, training, and then I'll go ahead and give in the password. So let me just type in the password over here. Right, so I have successfully logged into Putty. Now it's time to run the Kafka server. So I'll type in Kafka server start.sh, and then I'll type in Kafka /config/ and then after that I need to type in server. So let me write the spelling correctly. So this has to be server.properties. Let me hit enter. So let's just wait till the Kafka server starts. Right, so we see that we have successfully started the Kafka server. Now what I'll do is I will duplicate this session over here. And again, let me log in over here. Let me type in the password as well. So now that I've started the server, now it's time to go ahead and create the topic first. So this is the command to create a topic. So we'll just type in Kafka topics.sh, create Zookeeper. We'll set the localhost to be equal to 2181. And I'm setting the replication factor for this topic to be equal to 1. And I'm setting the number of partitions also to be equal to 1. And I'll set the topic name to be equal to example1. So I'll hit on enter. Now let's just wait till this topic is created. Right, so we see that we have this message, created topic example1. So now that we have created the topic, let's have a glance at all of the topics which are present now. So this is the command for that. So Kafka topics.sh list Zookeeper. So this gives us all of the list of the topics which are present. So it tells us that these are all the topics which are currently present. We've got example 1, example 2, Flume Kafka topic 1, consumer offsets, and my topic. So now that we have created the topic, it's time to start the producer to send the messages from this topic. So again, I will duplicate the session. Let me log in again. And I'll also type in the password over here. Right, so this is the command to start the producer. So Kafka console producer.sh broker list, and then I am sending this topic from the producer. So the name of the topic is example1. So the producer has started. Let me go ahead and type in some messages. So I'll type in, hello, how are you? I am good. Right, so these are the messages which should be sent from the producer to the consumer. Now I'll create another session and I will start the consumer in that. Let me type in the username and the password. Let me also type in the password again. And this is the command to start the consumer. So we've got Kafka console consumer.sh, and this consumer would be listening to this topic example1 from the beginning. So let me just wait till all of the messages are coming from the producer side to the consumer side. Right, so this is what we have. Hello, how are you doing? I am good. All right, now let me actually open up the producer again. Right, so let me add some more messages over here. So I'll type in Sparta. This is 300. Now let's see if we have these messages in the consumer as well. Right, so we have these messages in the consumer side as well. Now again, let me add some messages from the producer. So I'll type in, let's say, this is my first Kafka project and I love Kafka. Do you like Kafka? Let me just type all of this. Right, now let me go to the consumer side. Right, so we see that we have all of these messages on the consumer side as well. So this is how we can set up a single broker setup. Now let's see how can we configure a single node multi-broker cluster. So again, to set up a multi-broker system, so we'd have to start off by loading the Zookeeper service and as well as the Kafka service. So we'll type in Zookeeper server start.sh and then we'll load up this zookeeper.properties file. Similarly, we'll type in Kafka server /start.sh and then we'll load up this server.properties broker. Now once we start the Kafka service and as well as the Zookeeper service, we'd have to go ahead and create multiple brokers. Till now, we've just got one broker instance, which is already in the config/server.properties, right? So this file which we had loaded up earlier, this is basically the only broker which we have till now. Now to create multiple broker instances, what we'll do is we will copy this existing server.properties file into two new files and rename them as server1.properties and server2.properties. Now after we do that, we will go inside the Kafka/config directory and then we will create these files, right? So we'll go inside Kafka/config and then we'll create a copy of the original broker file. So we'll type in cp server.properties server1.properties. So we are just creating a copy of this original server.properties file and we are naming it to be server1.properties. Similarly, we'll create another copy of this file and we'll rename it to be server2.properties. So now that we have created our two brokers, we'd have to go ahead and make these changes in this. So we'll go inside the server1.properties file and we'll make all of these changes. So in our earlier server.properties file, the broker ID was 0. Now we'd have to make sure that each broker instance has a unique broker ID. So we'll give this new file the broker ID of 1 and this will be listening to the port 9093. So the original broker was listening to port number 9092. Now again, it needs to be kept in mind that one broker can listen to only one port. So that is why, since this is our new broker, this will be listening to a new port which is 9093. And again, we will make changes over here. So we'll set the log.ders over here. Now initially it was Kafka_logs. So we'll change this to be Kafka logs1. Similarly, we'll go inside the server2.properties file and we'll make these changes. So over here, we'll set the broker ID to be equal to 2 because this is our third broker. And this broker will be listening to the port number 9094. So the first broker was listening to port number 9092. Second broker was listening to port number 9093. And this broker which we've created would be listening to port number 9094. And again, we'll make changes over here. So we'll change this to logs2. Now, once we set up this, we'll have to go ahead and start all of these brokers which we've created. So the command would be same. We'll type in Kafka server start.sh and we'll load up this server1.properties. Similarly, we'll type in Kafka server start.sh and we'll type in server2.properties. So this is how we can start these two brokers which we have just created. Now that we have created the brokers, we'll go ahead and create a Kafka topic. So to create a topic, again, it will be the same. So we'll type Kafka topics.sh create and then we'll give the name of the topic. So which is topic example2. So example2 is the name of this topic. And then we'll type in -- Zookeeper and then we'll set the port of the localhost which is 2181. So for this topic which we are creating, we are setting the number of partitions to be equal to 3. Now we are setting the number of partitions to be equal to 3 because we have 3 brokers. Earlier, when we had set up just a single broker system, over there, since we had just one broker, the number of partitions were 1. And over here, since we have 3 brokers, we are setting the number of partitions to be equal to 3. And similarly, we'll set the replication factor to be equal to 2. Now to check which broker is listening on the current created topic, we can just use the describe command. So when we'll type in describe, we'll get an idea of which partition is listening to which topic over here. So now that we have created the Kafka topic, we have to do the same procedure. We'll have to start off the producer. So I'll create my producer over here, Kafka console producer.sh. And this time I actually have a broker list. So this would be sending messages to 3 brokers over here, which are listening to these port numbers 9093, 9094 and 9092. And the producer would be sending messages from the topic example2. Right, so these are the messages which are being sent over here. Bonjour, do you understand Kafka now? Hope you like this session. And then going ahead, we'll also start the consumer. So over here, I'll type in Kafka console consumer.sh and I'll start the bootstrap server. I'll set the localhost to be equal to 9093 and the topic is example2 because the producer is sending messages from example2 and this will read everything from beginning. Right, so now let's go ahead and perform this demo. So I've got my virtual machine running over here. So I'd have to do the same thing. I'd have to start off by loading the Kafka server. So I'll type in Kafka server. Let me type in the correct spelling over here. So Kafka server start.sh. After this would be Kafka /config/ and then I'd have to give in the server.properties name, server.properties. So let me just wait till the first broker starts. Alright, so we have successfully started the first broker which is listening on the port number 9092. Now we'd have to go ahead and start the other 2 brokers. So I'll duplicate this session over here Let me again load in. So I'll type in ID, which would be training, and then I'll give in the password. So the password is right. So I've given the password. Now, as we already know, we have the server.properties file. So I'd have to make a copy of it. So to make a copy, I'll type in cp, and the name of the file is server.properties, and I will make a copy with the name server1.properties. Now similarly, I'll make another copy with the name server2.properties. So I will change this to be server2. Alright, so I have created server1.properties and server2.properties. Now let me go inside server1.properties and make the relevant changes. I'll type in vim. Let me open this file up. So this would be server1.properties. Let me edit this. Alright, so let me go up and let me show you what exactly we are supposed to change over here. So as we see, we've got the broker ID to be equal to 0 because we've just copied the original file. So I will change this to be equal to 1. Similarly, I will go down, and wherever we have broker ID to be equal to 0, we'll set it to be 1. We'll make all of those relevant changes over here. So we'd have to do the same thing. Now, once we change all of the broker IDs to be equal to 1, let me just head down over here and let me show you what is the next change to be done. So a little more down over here. So you see this log.directories over here. So over here, I would have to change this to 1. Similarly, let me just go to the bottom of this page. And let me add a new line over here. So this time the port number would be equal to 9093. So the original broker, which was listening to 9092, and since we are creating a new broker, this would be listening to 9093. Now let me just press escape. I'll type in :WQ. So this would help me to save the changes which I have made to this new file. Alright. And now similarly, let me also make these changes in the server2.properties file. Let me type in insert over here. Let me just change all of these broker IDs. So this time I'll be changing the value of all of these broker IDs to be equal to 2. So this would be 2 over here. The value would be equal to 2. So I'll just delete the 0 over here, which is present, and I'll change wherever it is equal to 2. Now similarly, let me head down and go down to the server settings over here. So over here we have this log.dirs, and I will change it to Kafka logs2, and I'll head down to the bottom of the page. So over here, I'll set the port number to be equal to 9094. Let me hit escape and let me save this file. So :WQ. I'll hit enter. So we've made the necessary changes in server1.properties and server2.properties. Now let me again open up a new session. Let me create a duplicate session over here. So let me log in. Now I will go ahead and start these new brokers which I have created. Kafka server start.sh Kafka /lb config /server1.properties. Let me hit enter and let me just wait till the new broker which I've set up, which is server1, loads up. So you see that the new broker is starting. Now again, let me open a duplicate session again. Let me log in inside this. Let me type in the password. Now I'll go ahead and start the second broker. Kafka server start.sh, and after this I'll type in Kafka /config/ the name of the file is server2.properties. So now again I'll just wait till this loads up. So I have successfully started both of these new brokers over here. So now that I have started these two brokers, let me go ahead and also create my new topic. So you'd have to keep in mind that for every single thing which you're doing, you'd have to start a duplicate session. Now I'll type in the command to create a topic. So this is the command Kafka topics.sh, and I'm creating a topic with the name example2. And this topic would have 3 partitions, and the replication factor of this topic is 2. So we have successfully created this topic example2. Now I'll also go ahead and start the producer. So this is the command to start the producer. Kafka console producer.sh. So the broker list is localhost 9093, 9094 and 9092. So these are the three brokers which are listening through these three ports over here, and they are sending the topic example 2. Right. So now the producer has started, and let me just send him some messages over here. So I'll type in, I love, let's see, Paris. I also love India, and I love, let's say, Germany as well. So these messages we are sending from the producer. Now I'll again duplicate this session and start the consumer. So this is the command to start the consumer. So Kafka console consumer.sh, and this is listening through the port 9093, and this has subscribed to the topic example 2, and this will be processing it from the beginning, or it will be reading it from the beginning. So we have this result over here, right? So producer has sent these messages and the consumer has consumed these messages. I also love India, I love Paris, I love Germany as well. Right, now let me add something else over here. So let me load up the producer and let me add a few new lines. What I'll do is I'll just add some gibberish over here. So I've just added 4 lines of gibberish. Let me go to the consumer. So we have this 4 lines of gibberish over here. Right, so this is how we can set up a multi-broker system. Now we'll look at some basic topic operations. So let's see how can we modify a topic. So to modify a topic, we just have to use this alter topic command. So this is the entire command, but the main thing which you have to keep in mind is you just have to type in alter topic. So it is Kafka topics.sh Zookeeper, and it is listening through this port over here 2181. After that, I'll type in -alter topic, and then I'll give in the name of the topic which I want to alter. So this is the name of the topic, example 1. So initially when we had created this example, since it was a single broker setup, the number of partitions were equal to 1. Now since we have a multi-broker setup, I can actually set the number of partitions to be equal to 2. And this is the result which we get. So if partitions are increased for a topic that has a key, the partition logic or ordering of the messages will be affected. Alright, adding partitions succeeded. Now we'll see how to delete a topic. So to delete a topic, this is the command. So we'll just type in delete topic, and then we'll give in the name of the topic, which is flume topic 1, and this is the result which we'll get. So flume topic 1 is marked for deletion. This will have no impact if delete.topic.enable is not set to true. And when we go ahead and check the list of all of the topics available, we see that flume topic has been deleted. Now let's go ahead and perform this demo. So as we had seen in the PPT, so initially our first example 1 had just one partition. Now I want 2 partitions in it. So this is how we can make the changes. Alter topic example 1, and I'm setting the number of partitions to be equal to 2. Alright, so adding partitions succeeded. Now I'll go ahead and delete a topic. So now I actually want to delete the topic example 1. So I'll type in delete topic example 1. Let me hit enter. Right, so you see that example 1 is marked for deletion. Now let me go ahead and check the list if this topic has been deleted or not. So let me just type in this command over here. So list Kafka topics.sh list Zookeeper localhost 2181. And we see that we don't have example 1 in our list of topics. So this means that we have successfully deleted example 1. Right guys, so this brings us to the end of the session. So let's just go through a quick quiz. So this is our first question over here. So Kafka is run as a cluster comprised of one or more servers, each of which is called. So what do you think is the answer? The answer is broker, isn't it? Right, so you've got multiple brokers or a single broker in the cluster. So our second question, point out the wrong statement. So the first statement is, the Kafka cluster does not retain all published messages. Second statement is, a single Kafka broker can handle hundreds of megabytes of reads and writes per second from thousands of clients. The third statement is, Kafka is designed to allow a single cluster to serve as the central data backbone for a large organization. And the fourth statement is, messages are persisted on disk and replicated within the cluster to prevent data loss. So the wrong statement among these is, the Kafka cluster does not retain all of the published messages. Right.
Okay guys, a quick info. If you want to do an end-to-end certification on Kafka, Intellipaat provides a complete certification training on Kafka, and those details are available in the description. Now let us continue with this session.
We will set up a multi-node Kafka cluster. Then we will see some important administration commands, and after that we will see some Kafka tools that can help us in different operations on Kafka clusters. These operations can be graceful shutdown, balancing, the rebalancing tool that is going to be used when you expand your cluster or you decommission your cluster. You can also move the topics partitions from one broker to another broker using that rebalancing tool, and also you can increase the replication factor. Let us start with the multi-node Kafka cluster implementation. The next few slides are exactly same that we followed in our previous sessions, that is downloading the Kafka tarball and the Zookeeper tarballs. So I am going to cover these 2 or 3 slides very fast. This is the link that you can see on the web user interface from where you can download Zookeeper. Now the important setup is, so to complete the multi-node cluster setup, what we will do, we will first set up a single node cluster, and after that we will simply copy the Zookeeper and Kafka tarballs to rest of the servers and start the services so that they can join the cluster. So on the first node we will simply untar the directories, that is Kafka tarball and Zookeeper tarball. We will rename them according to our convenience. Then we will set up the environmental variables like Kafka home and Zookeeper home in .bashrc file. We will create the Kafka-logs directory where Kafka will store its data, and Zookeeper underscore home / zk data where Zookeeper will store its data. We will complete this step on first node, and after that we will make some configuration changes on the same node. Let us prepare the first node first. This is my first machine and I am having 2 tarballs here, one for Kafka and one for Zookeeper. I am simply going to untar them. Now I am going to rename these newly created directories. Now we have 2 entire directories, one is for Kafka and one is for Zookeeper. Set up the Kafka home and Zookeeper home in .bashrc file. I have done this already. This is the Kafka home, this is the Zookeeper home. The next step is to create the data directories for Kafka and Zookeeper. So I am going to make a directory at Kafka home Kafka-logs. This is my directory where Kafka will store its data. Similarly, I am going to create one directory for Zookeeper zk data. This is the directory where Zookeeper will store its data. Now we have completed the first step. Now we will make the configuration changes for Zookeeper and Kafka, and after that we will simply copy these Kafka and Zookeeper directories to rest of the servers. Now let us see what our slide says. We have completed this step. We will make the Zookeeper configuration changes first. For this we need to go to this directory which is present at Zookeeper home conf and zoo.cfg. The 2 important properties are the data directory that we will update and the last 3 lines where we are mentioning that we are having 3 Zookeeper servers which are running on naresh-hadoop1.abc.com. The second is running on naresh-hadoop2.abc.com. The third Zookeeper server is running at naresh-hadoop3.abc.com. Let us complete this first. I am going to the configuration directory of Zookeeper. Here you can see we have zoo_sample.cfg. Simply rename this to zoo.cfg. Open this file. First of all, just update this data directory. You remember we just created the directory home, Kafka, Zookeeper and zk data. This is the data directory where Zookeeper will store its data. Secondly, we are going to mention the names for all of the Zookeeper servers. The first Zookeeper server is going to run at naresh.hadoop.naresh-hadoop1.abc.com. The ports used will be 2888 and 3888, and the other servers, rest of the two servers is going to run on naresh-hadoop2.abc.com and 3.abc.com. Okay, this is the first part of the configuration changes for Zookeeper. What is the second part? Secondly, we need to create myid file and put the same integer used in server.x properties in zoo.cfg, which means we will create a file myid at this directory and we will put an integer 1 for the first Zookeeper server, 2 for second Zookeeper server and third for third Zookeeper server. So we are on the first Zookeeper server, so we will simply go to vi. The data directory is zk data. We will create a file myid here, and this is our first Zookeeper server, so we will simply put 1 here. This is simply to tell Zookeeper that this is my first Zookeeper server, and for the rest of the servers it will recognize that this is the second and this is the third one Zookeeper servers. If we are using only one Zookeeper server, we do not need to mention this myid file. Now we are done with the Zookeeper configuration changes. Let us make the Kafka configuration changes as well. For that, we need to go to the config directory of Kafka, and there we can see a server.properties file where we need to mention the zookeeper.connect property, and it will include all the Zookeeper server entries. You can see 3 Zookeeper servers. I think I skipped one property here, that is an important property, that is broker.id, and we need to put a unique integer in this field for every Kafka server. So we are on the first machine, so let us make the changes for Kafka as well. cd Kafka config. Here you can see this server.properties file. Let us open this and make the changes. You can see this is the broker ID for the first Kafka server. Let us you can start with 0 as well, so the rest of the 2 machines where we will run the Kafka server, we can simply put the broker ID 1 and 2 there, or you can simply start this 1. The main point is that the order should be sequential, like 1 2 3 or 0 1 2. So I am just putting 1 here. I am mentioning that this is my Kafka server and its broker ID is 1. This is the port that is going to be used, 9092. After that, I will make the changes for log.dirs, means the data directory that we created for Kafka. We created that at home, Kafka. Okay, this is the path that we created for Kafka to store its data. And the last property is zookeeper.connect. Here we need to mention all of our Zookeeper servers. All of the 3 servers I have mentioned here. So we are done with the Kafka configuration changes. Let us move to the slide now. the next step is to start the services. So whenever you set up your Kafka cluster, the important process is Zookeeper, because it is making coordination among all of your Kafka services. And if your Zookeeper is not running, the rest of the Kafka brokers and servers will not run and they will simply shut down. So first of all, we need to start the Zookeeper services on all the machines. By mentioning all the machine, I mean the machines that you have decided to be a Zookeeper quorum. In our case, we are having 3 Zookeeper servers, so we will need to start all of them first. And before starting these services, let us make the copy of Kafka and Zookeeper that we have done on our first node. We will simply SCP these Kafka and Zookeeper directories to node second and node third. Now I'm going to SCP the changes that we have done on this first node to second and third node. First, let me SCP the Kafka directory at second node, that is naresh-hadoop2.abc.com, and I want to copy that to home Kafka directory. Similarly, copy the Zookeeper directory to second node. We also made changes to .bashrc file so that we can set the environmental variable. Let us copy that too, so that we do not need to manually change this .bashrc on each node. Okay, so from this first node we copied Kafka directory, Zookeeper directory and .bashrc file to second node. Let us copy the same on the third node, that is naresh-hadoop3.abc.com. I am copying the Kafka directory first. Copy the Zookeeper directory now. And lastly, copy the .bashrc file so that we do not need to make the environmental variable changes manually. Okay, we have copied the required directories to rest of the servers. Now, the important thing is that the myid file that we created for Zookeeper should have unique value inside it, and the broker ID of each Kafka server should be unique. So on this first server, we are having the value for myid file is 1, and the value of broker ID for this server is 1. So on rest of the machines, for example on second machine, the value of myid should be second, that is 2, and the value of broker.id should be 2. Let us make these changes on second machine. I am on the second machine. You can see the directories are here. I am going to make the changes for myid. I am making it 2. Similarly, I am making this 3 on the third Zookeeper server. Now it's time to change the server.properties file, where we need to mention the unique broker.id. The broker.id for first server is 1. So let us put on the second server broker ID 2. No need to make any other change. Simply save this file. Do the same on third node. Open the server.properties. Go to broker.id. Make it unique and let us name it 3. So we are having 3 brokers, first, second and third. Okay, we are all set to go. Let us say what our slide says now. Now it's time to start the services, and as I said that Zookeeper is the main service that should be started at first, otherwise rest of the broker servers will not be working because they will simply shut down. Let us start the Zookeeper servers on 3 machines. This is present at the Zookeeper start.sh script is present at Zookeeper home bin sh start. You can simply do JPS and you can see we are having Quorum peer main, that is the Zookeeper services that we have just started. Let us start the same on second and third machine. Do JPS here. We can see the service is started for Zookeeper. Let us do the same for third node. Okay, so all of our Zookeeper servers are running. Now we can simply start the Kafka brokers. Let us start this on the first node first. I am simply copying this command. I am on the first node. I just use kafka-server-start.sh and I provided the configuration file, that is server.properties. Run the JPS command. We got one new service, that is for Kafka broker. Run the same command to start the broker at second and third node. This is the second node. I think we got some error. Let us see what is the error. Let us check the nohub.output file. There is nothing inside here. Failed to run command. Oh, got it. We have not we mentioned the Kafka home and Zookeeper home in .bashrc file because we scp that file from node first, but we didn't run this source.bashrc command which is required to set up the new variables. Now we have done this by running source.bashrc command. I think now we can start the server and it should be a success. Okay, we can see the second Kafka broker is also up. Let us do the same for third machine. First, let us do the source.bashrc, then copy the command to start the Kafka broker. Okay, we got our third Kafka broker up. So we are done with the multi-node cluster setup of Kafka. Let us move to the slides now. The next thing to verify is to create a topic. First of all, let us create one topic. We simply used kafka-topic.sh script. This is the command, the Zookeeper details, the replication factor, which is we are keeping 1, the partitions that we want only one partition, and finally the topic name. We got the output created topic test. We can simply verify this by running the list command. Okay, we got the output that we are having a topic and its name is test. We are done till here, and further you can simply run a Kafka console-producer.sh to produce some messages, and Kafka-console-consumer.sh to consume those messages. We have done this while we were setting the single node Kafka cluster, so I am simply skipping this step. This is the output that you can see on your screen when you will run the Kafka producer and Kafka consumer. Okay, as we are done with the multi-node setup of Kafka, let us move to some important administration commands that you are going to use generally. The first one is to create a topic that we just did. We ran this command kafka-topic.sh -create. We mentioned the replication factor, the partitions that we want, and finally the topic name. Then we check the same thing if our newly created topic is there or not using --list command. Now the next command is to describe. I want to see how many partitions my topic have, what is the replication factors, and what are the configurations that are already set for my topic. For that you can simply run this command, describe command. Let us run this. -describe -topic name. I want to check test topic. Okay, we got the output that we checked for topic test. We are having partition count 1. The replication factor is 1. Where is this topic present at present? I mean, on which server? Is it on the first node, second node, or third node? We can decide this by leader. Leader 2 means this is present at second Kafka broker. Replication, as we are having only one copy, so replica is also same, and ISR, that is in sync replica, that is also on the same node because we are not having any replicas. Let us see the next command. Now, as we were having only one partition, let us change the partition number to 3. We can use the alter command here, --alter. We can simply mention the partitions that we want. Let us do this. The command is -alter -partitions. I need 3 partitions now. I run this command. Okay, adding partitions succeeded. I can simply again run the describe command to see the details. This time we should have partitions count 3. Okay, you can see partition count is 3. Partition 0, 1 and 2. As we are not having, we are having only one replication factor. The only one leader is 2, 1, 2. Means for this partition is present at the first broker. This is present at the second broker, and this partition is also present at the second broker. Similar is the case with replicas. If we will have multiple replicas, then these will be mentioned here in comma separated form. Like if you are having the replica on first and second, then 1 comma 2 will be here. Okay. If you want to delete a topic, you can simply use -- delete. Further, if you want to change the configuration, for example, I want to set the maximum message bytes. You can see I'm setting this here. So earlier you can see that we are not having this configuration. I'm highlighting this part. Now let us set the new configuration. I'm simply copying this. I use the same command, that is -- alter, and provided the new parameter, that is -- config, and the configuration that I need to put. You can see the output, updated config for topic test. Now you run the describe command again, and you will see that earlier we were having no configs here, and this time you will see the newly added configuration here. Okay, you can see configs max.message.bytes is equal to this. This is what we have recently added. Now again, if you want to delete any configuration, you can simply use -- delete - config. Let us delete the newly added configuration now. Okay, updated config for topic test. Again, we can run the describe command, and we should not see this config max.message.bytes here. You can see it is gone. So these are some of the important commands that you might have need to run on the topics. Now, okay, so we are done till here. Let us move to the next slide. We are going to cover some important tools and topics in Kafka now. First of all, let us see what is a graceful shutdown. So when you have a up and running Kafka cluster, you can get some server downs. You can get these failures also, or you can simply keep these servers down intentionally for any maintenance purposes. So what will happen when a broker goes down or we take that down? Two things happen. First one is to sync all its logs to disk. It will be done automatically by Kafka. The second thing is to move all the leader partitions from that down node to rest of the nodes. It doesn't mean that we are moving the partitions manually, but we will simply transfer the leadership. For example, if we are having 3 replicas and the one, let us say one broker goes down and it was having one leader replica, so now the leadership will be transferred to rest of the replica partitions. So to make this happen at every stage, we need to set this property controlled.shutdown.enable is equal to true. If this property is set, the leadership election will be done automatically by Kafka. Okay. And one important point to note here is that if you are having only one replication factor, then this control.shutdown.enable is equal to true will not have any meaning, because Kafka needs some replica copies so that it can transfer the leadership to that replica copies. Let us move ahead now. Now, balancing leadership. So what will happen, as we know that as soon as a node will go down, a broker will go down, all of its partitions leadership will be transferred to its replicas. Consider that node came back up. What will happen then? as the leadership has been already transferred, the broker that just came up will simply work as the follower, which means that all reads and writes will not go to that node because the partitions that are present on that broker are only followers. There is no leader. So what we got? We got imbalance. To maintain or to handle this kind of situation, we need to run this Kafka-preferred-replica-election.sh script. As an example, you can see on the screen that if the list of replicas for a partition is 159, okay, then node 1 is preferred as the leadership to either node 5 or 9 because it is earlier in the replica list. You can tell Kafka cluster try to restore the leadership to the restored replicas by running the below command. In this scenario, if node first goes down and then it simply comes back up, after that you can run this script to restore the leadership back to node 1. As we or nobody like to do the manual work, we can simply automate this by setting this property auto.leader.rebalance.enable is equal to true. Now expanding the cluster. In Kafka, it is very easy to add a node or to expand your cluster. To do that, you simply bring a node, copy the Kafka tarball or the Kafka configuration directory from any of the node to that new node and put a unique new broker ID in the server.properties file. After that, you simply start the service Kafka broker services and you are done. But what about the rebalancing? Means the new broker will not have the data automatically by itself. If the new data will come, that will simply go or will be distributed among all the servers. But till then, consider some of the topics are some of the brokers are heavily loaded and we got some new broker server. In that case, we will need to run the balancer manually. How can we do that? For that, we can use partition reassignment tool. First thing is that it is not automatic. We need to run this manually using a script. This tool has 3 modes. First one is generate, second one is execute, and the third one is verify. Generate will take some inputs like what is the topic name and where do you want to move them. It will take the topic names and the broker list where we want to move those topics. After that, it will generate a result that this is your proposed result, that this is what you want. If we are satisfied with that, we can simply copy that into a JSON file and then run the next mode, that is execute mode. This is the important mode that will actually move your topic from one broker to another broker. And the third mode is the verify mode. After the completion of execute mode, we can simply run the verify mode and it will tell us whether our target was successful or not. Let us take an example. We will create 2 topics, that is foo1 and foo2, okay, with replication factor 1 and partition 1. After that, we will see the locations of these 2 topics and then we will try to move them from that location to some other broker. Let us first create these foo1 and foo2. I am on the first node. I am going to create foo1 . Similarly, I am going to create foo2. Now let us describe these two newly created topics so that we come to know where does they exist actually. You can see that it is having one partition, that is partition 0, and it is present at third broker. Let us see where does the second topic, that is foo2, where is it present now. Okay, you can see it is present at second broker. Now first of all, we need to create a JSON file because this tool works on the JSON file only. In that JSON file, we will simply mention that I want to take action on these topics. Okay, let us copy this JSON format from here. Okay, we will simply name this topics to move. We will create a file topics to move.json. Okay, I have just pasted that contents here. Okay, you can see we are taking action of foo1, taking action on foo1 and foo2. Just save it. So we will run our first mode, that is generate mode. That will simply tell us that you are going to take action on these topics, and these are the new broker list where this topic will be moved to. So I am just taking this command from here. Generate is the mode that I want to run. Okay, you can see topics to move JSON file. This is the file that we created where we mentioned that we want to move foo1 and foo2. Okay, so our foo1 is present at third broker, so I'm going to move that to first and second, and the foo2 topic is present at second. So let us see what will happen when we will run this. Okay, I think we are not okay with the command. Let me check. Let me copy the complete command and then see what happens. I think the command is not correct. So just let me check it from the internet. What is the exact command? Okay, so this is the exact command, and let me see what we are missing here. I'm just copying it, pasting it into the first node, just updating the broker list, file is same, updating the Zookeeper server as well. Okay, now I'm pressing enter. Now it should generate a proposed JSON file. You can see the current partition replica assignment is foo1 is having partition 0, which is present at third machine. foo2 is having partition 0, which is present at second machine. And the proposed partition reassignment configuration is that we want to move foo1 partition 0 to the first node and foo to partition 0 to first node, means we are going to move both of these partition to first node. Now it's time to run the execute mode. Let us run the execute mode now. Okay, before we do that, we need to create a file where we will store the proposed results, and we will use that file to run the execute mode. So I'm going to create this file, expand cluster reassignment.json. What I'm going to put in there, the proposed results, that is this. Simply save this. Now run the execute mode. Okay, so you can see we got successfully started the assignment of partitions. We will now run the third mode, that is verify mode, which will just confirm that our target was successful or not. This is the command that we will use to verify. You can see that the reassignment for foo1 partition 0 completed successfully, for foo2 partition 0 completed successfully. Let us move ahead with the custom reassignment. By custom reassignment means that earlier we were completely moving one topic from one broker to another, but consider I want to move some partitions only. Consider a topic is having 3 partitions and I want to move the first partition only to some new server. In that case, what we will do, we will, just like earlier, we will simply run these 3 modes. Okay, the generate, which will show the proposed results, then we will do the execute mode, and finally we will do the verify mode. Okay, so in this screen you can see, consider if I want to move partition 0 of topic foo1 to some brokers and partition 1 of topic foo2 to some other brokers, we will simply mention in the custom -reassignment.json file that topic is this. I want to move partition 0 and I want to move to these 2 nodes. I want to create replicas at these 2 nodes, 5th or 6th. Similarly, for foo2, I want to move partition 1 and I want them to move to 2 and 3. This is called custom reassignment. Nothing has changed, we just updated our JSON file. On that, we want to run the execute and verify mode. We will then simply run the execute mode and then simply run the verify mode to verify if we got success or not. Now, how to decommission a broker? So this functionality is not there in Kafka, means there is no tool to decommission a broker. So your admin will have to manually move your topics from the broker that you want to decommission to some other broker, and after that you can simply shut down that broker and that will be decommissioned. So in future release of Kafka, we may have this decommission tool, so that we do not need to take actions manually. Now, in my previous session, I said that we cannot increase the replication factor. So by that mean that we cannot simply, run the alter command to change the replication factor. If we want to change the replication factor, we need to use this reassignment tool. Okay. So for that, we will simply add this replica thing. You remember earlier we were simply mentioning the topic name, then we try to do the custom reassignment by mentioning the partition name, and now you can see we can also mention the replicas that will increase the replication factor to the number of servers that are given in this field. Okay, now let us try to do this thing. Let us prepare this file, that is increase replication factor.json. We are going to do this for foo1. Okay, I open this file. I am just copying these contents in the JSON format so that I do not mess up with the format of JSON file, that because it is a very critical thing. I am changing the topic name to foo1, and I am saying that I want the replication set 1, 2 and 3. I want this on all 3 brokers. Now we will run the execute command, that is this. Simply copy it and run it. You can see we are using this increase -replication -factor.json file that we just created earlier. You can see we got successfully started the assignment of partitions of foo1 to these 3 brokers. Let us verify this by verify command, if our reassignment was successful or not. Okay, we got the result that foo1 partition 0 is completed successfully. We can also verify this by running the describe command, and earlier we were having only one replication factor, so let us see what this shows us this time. Okay, you can see partition 0 replication factor has been changed to 3, and these 3 replicas are present at first, second and third node, and in sync replicas means all the replicas are in sync.
Okay guys, a quick info. If you want to do an end-to-end certification on Kafka, Intellipaat provides a complete certification training on Kafka, and those details are available in the description. Okay guys, we've come to the end of this session. I hope this session on Kafka was helpful and informative for you. If you have any queries regarding this session, please leave a comment below and we'll love to help you out. Thank you.